Hi students, today we are going to discuss one more question, that is this is the question from CBSE 2025 question paper, code number 5553 and question number 25. You know, every year there are 6 to 7 codes are there, paper code, and each code there are 3 sets are there. So difficult to solve everything, you need time to solve everything. So here is the question. A right-angled prism ABC refractive index square root 2 is kept on a plane mirror as shown in the figure. Okay. A ray of light is incident normally on the face AC. Then what we want to find is, first we have to trace the path of the ray as it passes through the prism. The second, find the angle of deviation produced. Okay. We will discuss the concept now. To start that one, we should have some idea about the refraction of light. You started learning refraction of light from grade 7 or 8, right? That is the bending of light. When the light travels from one medium to another medium, it bends. That is actually the refraction of light. Okay. And there are two laws associated with the refraction of light. Laws of reflection also there are two. Here the first one is incident ray, the normal to the refracting surface at the point of incidence, and the refracted ray all lie in the same plane. Second one, there is a speciality. It is related to a law also. The name of the law is Snell's law. Okay, that is, it is the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant. The name of the constant is refractive index. Okay, so based on this, we are going to solve our numerical. Now, another one concept you want to learn is total internal reflection. One of the important question in grade 12 CBSE examination from the chapter number 9, ray optics. What the speciality of this question is, based on this question, two type question is asking. One is what is total internal reflection. Second one is what are the conditions required for total internal reflection. This also in the theory maybe you have already learned. What is showing here is when the angle of incidence start increasing, angle of refraction also increasing, and when for a particular value of angle of incidence, the angle of refraction become 90 degree. The name of that particular angle of incidence is critical angle. Have so much important. And if the angle of incidence greater than the critical angle, what will happen is the incident ray will be reflected back to the same medium. This phenomenon is known as total internal reflection. To happen this one, two conditions must satisfy. Condition number one is light should travel from denser to rarer. Condition number two is angle of incidence should be greater than the critical angle. Okay. And there is a relation between critical angle and the refractive index. We are using this in this numerical also and also for MCQ. What is that relation is refractive index is equal to 1 divided by sine IC or sine C. Basically sine of the critical angle. Okay. So that also you remember because we want to use it from the refractive index. Sometimes we want to find the critical angle. In some scenario from the critical angle you want to find the refractive index. Okay, let's start now. This is the diagram given in the question. I just pasted that copy here. And how much given in the question, that much I marked already here. From this point we want to start drawing. And before drawing we have a small work from the refractive index data. So we are writing that one like a given refractive index is equal to square root 2. Given here in the question. And we know one relation. Just now we wrote that relation. That is the relation between refractive index and the critical angle. I am going to write that one here. N is equal to 1 by sine IC. And here N is given, right? Here N is square root 2. So what we want to find is critical angle we want to find. Here IC stand for critical angle. Okay. So we are going to substitute the value now. In the place of N, square root 2 is equal to 1 divided by sine IC. Now we do a small cross multiplication. So right side denominator we will take to numerator, left side, and the left side numerator will take to denominator. So sine IC is equal to 1 by square root 2. Then IC is equal to, usually we take sine inverse, right? Sine inverse 1 by square root 2. Try to remember which value for sine 1 by root 2 is coming. That is 45. So critical angle given here or found here, IC is equal to 45 degree. Why we want critical angle? Because based on angle of incidence and critical angle, we will decide total internal reflection. So you know that angle of incidence is 0, angle of refraction also will be 0. So here the incident ray will pass through straight. In my drawing there is a small bending, but basically you assume that there is a straight line. So when angle of incidence is 0 with the normal, angle of refraction also will be 0. So it is going straight. Now do a little geometry calculation. You see the triangle is here, and one corner of the triangle, that position A is, point A is 60 degree. 90 degree is there when the light entered. So 60 plus 90, you know that one, that is 150, right? So 60 plus 90 is 150. So the remaining angle will be using angle sum property, 30 degree. Okay, I showed here the working. Now what will be the angle of incidence at the point Q with the normal? Since total is 90 degree, 30 degree already we found. So other angle will be 90 minus 30, that will be equal to 60. Now you see the angle of incidence, we found it 60 degree. Critical angle already we found there 45 degree. Condition satisfied, right? Total internal reflection condition is, if angle of incidence greater than critical angle, total internal reflection will take place. It happened now. And also follow the rules for loss of reflection. At the normal, at the point Q, 60 degree angle of incidence, so reflection also 60 degree. Now that ray hit on the mirror side. So what happening there, check it. Angle again calculate. How to calculate is 30 degree, because from 60, 30 degree at the point Q you can see there. 90 degree at the point B, that is the vertex at corner. So 90 plus 30 is how much? 120. So the remaining value is, we will calculate that corner 60. So with the normal, 90 minus 60, that corner will be, that normal will be 30 degree. So angle of incidence is 30, angle of reflection also 30. Okay. So now the time to calculate the things. What happened to the refracted rays, the deviated rays? Deviation is it coming out of the prism after total internal reflection happened at the point Q, and 180 degree deviation taken here. So the question was that one. Now here see the angle also showing now. So how much angle is this corner angle? How to get that corner angle is, see at the mirror point intersection, there you can see that 30 degree, the remaining will be 60 degree. Yeah. And the corner point C is from that 90 degree, it will be, total is 180. So 90 plus 60 plus 30 is 180 degree. So what is the conclusion here is, the ray will be coming out from the prism by making angle of deviation 180 degree, 90 plus 90. So that is also one question, right? Angle of deviation, what is the value of angle of deviation? So angle of deviation is 180 degree. So how is this question? Is it easy to do? Just you want to practice one or two questions like this one, then easily you can do this type of question. But understand one thing, geometry questions always need practice. Without practice, very difficult to remember this type of stuff. We'll feel like we can do it, but when we practice only we'll come to know that that is difficult. Here the mark distribution given was total 3 mark. Out of that 2.5 mark they assigned for drawing work only. And only the half mark, 2.5 plus 5, that half mark given for finding the angle of deviation. What do you feel about this numerical? It's good? See, like this we can have so many numerical. In the next video I will come with another one numerical, which will be a little bit tough, because we want to practice tough questions. Then we want to revise all the questions.